So we're right here at the ID Tech X show, and who are you?
My name is Topher Anderson, and I'm a textile engineer here with ZSK.
So what is ZSK?
So ZSK creates different embroidery machines for customized applications. So e-textiles applications, composites applications, different high-tech applications that might use different types of textile engineering or flexible substrates.
So this is an e-textile machine?
So this is a traditional embroidery machine that we've converted into different types of e-textiles to be able to run different samples from flexible circuits to different types of sensors.
So you've converted a textile machine to work with all these sensors. How do you, can you stop the machine?
Yeah, sure.
So how do you get all this stuff happening in there?
So what we have here is we have a capacitive touch sensor. This is a self-capacitance sensor. And what that does is that allows us to detect the capacitance of a person touching it. So this creates a keyboard that somebody could play. We also have a conductive path that travels up through the individual e-textile, and that is terminated and connected automatically through the board. So what we're trying to do here is to create a single-step manufacturing process to be able to create the sensors, the connections and routing, and then also to connect them automatically to the board so there's no post-solder.
You're not able to do all this with this machine, right?
All of that's done with this machine right here.
That's it?
All of it is just with this machine. That way there's no soldering or cutout or anything else with it.
And it's real?
Yes, so we have a functioning demo over here of this piece. And so what we have here, if you play the piano, you hear a couple different sounds throughout the pieces. Each one has its own pitch and note, showing that all of these capacitive sensors are functional, connected and terminated into the board, and this comes off exactly how you're seeing it.
And you can put it on a pillow?
You can put it on a pillow, you can put it on a t-shirt, a sweatshirt. The technology doesn't matter, doesn't eliminate different types of base materials.
And what happens with this one?
So in this one right now, I'll hold this up for you. This one we're using LED sequins. So we have technology that allows us to place sequins down, and sequins are exactly what you would think on like a ballerina dress, like a kid's dress. And so with this, we have a whole bunch of different sequins that we can put LEDs, different electronics on, and that allows us to create a very, very flexible substrate.
Where's the electronics?
So the electronics are built into these tiny little sequins right here that are stitched into the piece. And then we have 2 terminals for battery right now, but that could be some other type of customer.
So you said this machine does everything, really? Like, what's the material in here, and where do you put it in the machine, and how does it get down and everything in there?
So here we're using a silver-coated nylon by Madeira. It's a company that we've worked with a lot on different conductive threads, and that seems to run very well on our machine. So what we do is we have our thread base over here with a bunch of different colors. I think on this machine we have 12. Some of our machines go up to 24. And we can take one of these, and I think it's right in the middle there, you'll see that's the conductive thread.
So the one that's maybe this one?
Correct, yes.
That one is a conductive thread,
yes.
But it just acts like a thread?
It acts like a normal thread, and that allows us to use the traditional processes for embroidery to be able to do stitching and to be able to create different sensors and connections.
But the PCB, you have to put it manually later?
The PCB is the only manual part that you have to put, so we create a little textile jig, and that allows us to lock our PCB down, and from there on out, it does the rest of the stitching automatically.
Do you have any smaller PCB designs?
We do over on the other side. I can show you some of that.
Because if you want to put it on the clothes, you want to have something very compact if it's PCB, right?
Absolutely. So I can actually show you on this one, we have...
Yep.
So on this one, we have a smaller board that we designed in-house, and this board is optimized for embroidery.
Yep.
And then on top of that, we have up here, you'll see small little LED sequins, again, similar to the other technology, but as long as the chip can be mounted onto a sequin, we can place that down and connect it electrically very reliably.
So what does it do, on off?
So on and off here, and this be able to set a capacitive set to be able to test and reset this little game. And then what happens on this game, it says you tap over here on the hand, and that's going to start this game, and it says press the top left red triangle, and once you do that, it gives you one further in the design that you have to follow through to be able to get to the end of the design. So a simple little game just detailing how we can embroider different types of connections.
Wow. What are you doing with this seat?
So another one of our technologies that we use does tailored fiber placement or tailored wire placement. And this technology is a little bit different than the previous embroidery machine that I showed you. And this allows us to zigzag over a thicker conductive material or a tube or carbon fiber or something that is in general too thick to run through the top of the machine. And so with that, we're able to create composites or different types of structures, e-textiles, thick wires, Ethernet cables, materials, again, that you could never run through an embroidery machine itself.
And what is this? This is stylish? And what does it do?
So this is a project that we worked on in collaboration with the school. And what happens with this jacket, each one of these is a connective snap. And whenever you snap that in, that allows a connection to be made, and that allows different sounds to come off.
Ooh, sounds.
So, sounds. And then up here, we also have a hat that we had worked on, and this has the LEDs built directly into the hat. And so that
for what's called Halloween.
You could use that for Halloween, for however you want to use it.
So what is the sound? Can we hear it, or?
So the sound, let me check if the speaker's in here. I think the speaker needs to be recharged on this one, but we might get that down later.
And then you could just close one button and
it makes an animal sound that corresponds to that button, yes.
That's awesome, cool. So where are you based?
So our main company is based over in Krefeld, Germany. I run a facility out in Seattle to be able to do different prototyping or work with customers on their unique designs to see if it's feasible for our technology. But all the machines, all the technology is developed and built over in Germany.
So does that mean there's like, what's it called, some kind of, where people work on different hacking room hackathons?
Sort of.
Hacking kind of projects?
That's kind of how I've set it up.
Something mass production also?
So we have, the machines that are here are all very small, our smallest machines. We have machines that go up the entire size of a factory floor. And those are the machines that use for production level, not prototyping.
Nice. What does this one do?
So this one is another example of LEDs built into, in this case, a sweatshirt. And this one has different LEDs that we can change different positioning, different light brightness settings, and that allows it all to be put into a single garment.
What is this?
So over here we have a foam and leather. So this is a thicker material, and what we're able to do here is this is more used for automotive industry. So we're able to do automotive grade stitching around the outside for decorative. And we also use our different chip technology to be able to integrate LEDs into this piece.
Nice. And this one?
So this one is a fun piece. This piece is a car dashboard that we're using to demonstrate a couple different pieces of our technology. So with this dashboard, you'll see that there's actually a board here that we can interact with, capacitive touch. And the capacitive touch, all of the sensors are actually underneath on this piece. So from here, what we're doing is we're embroidering our board in. We have each one of our sensors integrated in. We also have our LEDs in, and this is all done as a single-step process. So there's no soldering or there's no other setup required other than putting the board into the hole. And so we actually have a functional one of those over here if you'd like to see.
And that would be what kind of market?
So this we're looking at different automotive or different interaction technologies market, although it could be applied to a whole bunch of different markets inside.
Nice. Whoa. That's it's interesting to touch stuff and then something is different.
Absolutely, absolutely.
So what's next? Do you think there's going to be a huge future for smart textiles? Are you going to be a big part of that?
So I think from my background in textile engineering, I think that from an embroidery standpoint, I can create complexity of designs and be able to change my machines very, very quickly to run one type of sample 1 hour or a totally different type of second hour. Yeah. And I think that allows for the highest amount of flexibility with design, which is what we're looking for e-textiles.
How does it work? What is this software system here?
So this is all developed in company, so we do all of our own software, firmware development, and machine development. But what we can do is we can take a DXF or some other type of vector-based file, and the vector-based file we can use as a path to be able to create stitches on top of it.
So does NSK have been doing this kind of machines for a long time?
So we've been doing traditional embroidery machines with ZSK for quite a while. Now it's probably in the last 10 years that we're starting to really reach out to different markets, specifically e-textiles.
But otherwise it's been like decades and decades of being a market leader in this kind of stuff?
It's a very, very mature technology, yes.
Yeah. And what is this bird doing?
So our bird. Yes, so our bird here, we have a very different type of embroidery. So this is called K-style embroidery. So a K-head embroidery uses a chenille stitch, or essentially loops of material, to be able to create something that feels like the top of a terry cloth or a towel. And with that, we're able to create high surface area to be able to do things like create electrodes or electrode stimulation. So with that kind of technology, because it has such a high surface area, we're able to get a really good reading off of EMG or electroencephalograms. We're also able to do the reverse of that to be able to stimulate a region with TENS
So just
device.
wearing a t-shirt is enough to get a heart rate?
We can get a heart rate off of that, yes.
Very good heart rate, that's it. No need to have it very tight or anything?
No, well, you want it to be at least tight enough so you don't have false signals. But other than that, the technology allows you to reduce your need for like saline gels or traditional gel-based materials that go on electrodes.
So are you the market leader for this kind of tech?
I would think so.
Yeah.
Definitely.
There's some competitors, right?
There are a few competitors, but I don't think they're as advanced or mature in some of the e-textiles and composites work that we're doing. So I think that leads us out to a very unique position to be in right now.
And here at the Aditech X Show, I think I've seen some companies that have different kinds of propositions in terms of doing those threads, maybe.
Right.
Are you reaching out to new threads that can do different things?
Absolutely. So we're always looking for new materials to work with, new base materials, new threads, new ideas to try. So if any of those ever come up, feel free to reach out. We'll see if it's a possible fit.
Have you had some good discussions here at the Aditech X Show?
Absolutely.
Some people
new
like,
ideas,
how can we do more?
Things that we want to test out a little bit more, see if it's a good fit. So I'll run those samples in my lab back in Seattle when I get back there.